Hey there guys, it's Mrs. Rubery, and today we're going to be reviewing two-dimensional geometry. So you should have a copy of the 6th grade PSSA reference sheet with all the formulas. Here's a few that you'll definitely be using. So we have the triangle formula, area equals 1/2 base times height. We talked about how that particular formula, instead of doing 1/2 times base times height, if it's easier for you, you can do base times height divided by 2. Underneath it, we have the rectangle with area is length times width. Over on the right, we have a trapezoid with 1/2 the height, which is the same as taking the height divided by 2, multiplied by the sum of the two bases, and then the parallelogram, which is base times height, and we'll review these in more depth. But you definitely want to have your 6th grade PSSA formula sheet that will be available for you for the final and anytime you ever have a geometry test. All right, so one of the first things I want to review is it's important to be able to identify the base and the height on polygons. Many of the formulas use that. The triangle uses it, the trapezoid uses it, as well as the parallelogram. So we need to be able to identify that very easily. So when we're looking for the base and the height, we need to find the right angle, and that right angle is connecting the base and the height. So taking a look at that first triangle, the right angle is here in that red square. So the base would be down here on the bottom, and the height is a dotted line. So that height's not a side of the triangle, it's just showing how tall it is. Now the triangle below it is a right triangle, which changes things up. There's no dotted line because the right angle connects the base, which is a side of it, and the height, which is another side, because it's a right triangle. Taking a look at the parallelogram in the center, I have a right angle here. Our base is down here at the bottom, and it makes a right angle with this dotted line, which is the height. Every parallelogram is going to have some sort of dotted line showing the height because the sides, the two sides going up from the base, are diagonal. Sometimes you'll see a dotted line extend out from the base and up like this. And then in that case, I'm going to use a different color highlighter. Our base, that's not highlighter. Our base is still just that solid line, and our height would be here. And then in our last example with the trapezoid, in a trapezoid, there's two bases. The bases are the parallel sides. So I have this base and this base, and both of them form a right angle with the height. Now, sometimes on a trapezoid, the height can also be a side. So for example, I might have a trapezoid, not a real great picture, but looks something like that. In this case, our base and height are here. There's another base up top. All right, let's start practicing with our formulas. If you remember, when we're doing area of any of these shapes, I require you to write down the formula, substitute in the numbers, solve, and label. So using your formula sheet, we can get the formula for a parallelogram is area equals B times H. We're going to identify the base and height, look for the right angle, and we have an 8 and 4. So area equals 8 times 4. And solve and label, so area would be 32. And this happens to be centimeters squared. All right, here's another parallelogram. So the area equals base times height. Get that right from your formula sheet. Looking here, I have a right angle which connects the 2 and 5/10 and the 1 and 8/10. So area is equal to 2 and 5/10 multiplied by 1 and 8/10. And you will be able to use a calculator for this portion of the math final. So when I multiply those, I get 4 and 5/10. This time it's meters and it's squared. All right, moving on to triangles. We know the formula of a triangle is area equals 1/2 the base times the height, or if you prefer, area equals the base times the height divided by 2. We know from working with fractions, multiplying by a half is the same as dividing by 2. So we find our right angle, our base, and our height. So substitute area equals 1/2 of the base. Oops, let me go back to that. I don't know what happened. Okay. Just going to go forward to where we left off. Okay, so area equals 1/2 of the base times height. So area would equal 1/2 of 12 times 5. 1/2 of 12 would be 6. So 6 times 5 would give us 30. So area equals 30. If there's no label here, okay, we're going to use units squared. Take a look at another triangle. This one's not a right triangle, so the base and height are, there's a dotted line for the height, so we got a base of 12 and a height this time of 4. Area equals 1/2 the base times the height, so area equals 1/2 of 12 multiplied by 4. When I do that multiplication, we get 24 units squared. All right, one more triangle. This one is the red triangle. Gets a little confusing with all these numbers. So our base is here. It has to be part of the triangle. So it's 7. 10 is not the base of the triangle because the triangle itself is this shape I just colored in with blue. So the base is only the 7. And the height is straight up and down. Here's our right angle. So it's 4. Area equals 1/2 of 1/2, forgot the formula, the base times the height. So area equals 1/2 of 7 times 4. And 1/2 of 7 times 4 is going to give us an area of 14 square units. All right, moving on to trapezoids. So a reminder that the two bases are the parallel sides. So it doesn't have to be the top and bottom. It depends on how the trapezoid is arranged. It could be sideways, so you want to be careful. Okay, and the height is perpendicular to the bases. All right, so area equals, for a trapezoid, again, look at your formula sheet, copy down the formula so you get it correct. 1/2 of the height, or the height divided by 2, and add base 1 plus base 2. Now, as far as which one's base 1 and base 2, that doesn't matter. So our parallel sides are 10 and 6, and our height is perpendicular with 4. So I'm going to substitute in area equals 1/2 of 4, and the bases are 10 and 6. And when I figure that out, 1/2 of 4 is 2. 10 plus 6 is 16. 2 times 16 gives us 32 square units. All right, here's another one, a little bit different. This time, the bases still are on the top and bottom, but the height is a side of the trapezoid because it has a right angle. So copy down the formula, 1/2 the height, add the two bases. So the height was 4, 1/2 of 4, and we're going to add the 8 and the 5 together this time. So 1/2 of 4 is 2, and multiply that by 13 to get an area of 26 square meters. All right, now love this one because it makes you really take a look at it to figure out which ones are the bases and height. So remember, bases are always parallel. So the 15 and 7 are parallel to each other, so those are our bases. They make a right angle to 15, so 15 is your height. Area equals 1/2 the height, add the bases. The height we said is 15, so 1/2 of 15 and add 15 and 7 for your two bases. So a half of 15 is 7.5. Add together your 15 and 7 to get 22. Multiply that and we get an area of 165 meters squared. All right, now we're going to take a look at area on the coordinate plane. So we have a triangle, area equals 1/2 the base times the height. And we need a base here and a height here, and we have to figure out the distances. So this point on the bottom left, right here, is located at -7 on the x-axis. And this point here is located at 5. The distance between a -7 and a 5 is 12. Another way to do it is you could do your hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But using your distance formula works a lot better. And then we need the height. So now we're looking at the y-axis. This would be -1, 2, 3, 4, -4 on the y-axis. And this other dot is at 6. So the distance between those, we have different signs, so we're going to add, would be a distance of 10. And again, you could hop it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So substituting in, we have 1/2 of 12 times 10. So 1/2 of 12 is 6 times 10 would give us an area of 60 square units. Now I have a parallelogram. I like this one because it makes you have to look at it kind of sideways. Remember that the bases, when you're looking on a coordinate grid, the base has to be along the lines of the grid. So here's a base, and our height would be straight up like that. Okay, so area equals base times height. For the base, this top point here is located at 1, 2, 3, 4, 5 on the y-axis. And the bottom point is at -1, 2, 3, 4, 5, 6, 7, -7. The distance between a 5 and a -7 is 12. And again, you could kind of count that out. And then finding the distance, the height here, this is located at 2 on the x-axis. And this point here, let's see, 3, 4, 5, 6. So they're same sign, so I would subtract them. Or you can hop it, 1, 2, 3, 4. So area is equal to 12 times 6. 12 times 4. I was writing down the coordinate instead. So area would be 48 square units. All right, moving on to composite shapes. Composite shapes are made up of 2 or more polygons that are joined together. So to figure them out, we have to separate the shape into familiar polygons that we know, find any missing lengths of sides, find the area of each of the polygons, and then combine, add together the areas for a total area of the composite shape. So we have 3 of these to practice. Okay, here's our first one. Now, how you break this up is up to you. You could break it right here and have 2 different rectangles, or you could break it vertically right here. I'm going to break it vertically and take a look at my 2 rectangles. So the rectangle on the right, here's our 6 for a length, and here's our 2 for a width. So for this section, area equals length times width. So area would be 6 times 2, which would be 12 square centimeters. Now let's take a look at the other one, a little bit trickier. We need this length here, and it's not given to us. But we do know the whole bottom is 10, and this part is 6. When we're given a whole side and part of a side, we're going to subtract them. So 10 minus 6 gives us a distance of 4 centimeters for that top. And we can already see then, so this is 4 by 9. So area equals length times width, and area would be 4 times 9, which would be 36 square centimeters. And then to find the total area, we're going to add them together. 36 plus 12 will give us 48 square centimeters for the entire composite shape. Let's get a little trickier with this shape. So on this one, again, there's two different ways you could separate it. We could separate it here and do a rectangle and a trapezoid. Or we could separate it here and again do a rectangle and a trapezoid. I'm going to keep it at this separation. Let's look at the rectangle first. It's easier. We have 5 by 10. So area is equal to length times width. Area equals 5 times 10, which would be 50 square inches. And then the trapezoid is definitely a little more complicated. So the bases, here's a base and here's a base. We know one's definitely 7. The other one's not 15 because 15 is the entire length across here. So we have to look at all the sides that are parallel. So the entire distance is 15. Up top, that's 5. So if I subtract the whole thing from the part, 15 minus 5, gives us a base of 10 inches. We're going to do something similar to figure out the height, which is right here that I put in green. So for that height, I know the entire length over here is 10, part is 6. So 10 minus 6 would give us a height of 4. All right, I'm going to put this over here. So area equals 1/2 of the height and add the bases. So we have 1/2 of 4, and we're going to add 15 plus 7. So that would be 2 times 15 plus 7 is 22. 2 times 22 is 44 square inches. Oops, I put the wrong thing in. I apologize. It wasn't 15. I'm sure you're saying, Mrs. Rubery. The base was 10 there, not 15. Common mistake to make. 7 and 10, which we already talked about. So it is going to be 1/2 of 4, which is 2 times 17, which is going to give us 34 square inches. So be careful that you don't make the same mistake that I almost made there. We did all that work to find the missing side and then didn't use it. All right, the total area, we're going to add those two together. So 50 square inches plus the 34 square inches gives us a total area of the composite shape of 84 square inches. All right, last one. Last one is kind of looking like a house. So the best way to divide this one, here we go, would be right across there at the roof. So we have a rectangle, a length and a width of 12. So to solve that one, we're going to do area equals the length times width. So 12 times 4 is going to give us 48. And now we need the triangle. So for the triangle, the base of the triangle here is the same as the base of the rectangle. So we know that's 12. The height's going to take a little bit of calculation. So let's take a look maybe at what the height's going to be. If the entire house is 10 and this part is 4, to get this height, we're going to subtract. So 10 minus 4 gives us a height of 6. Area is equal to 1/2 the base times the height. So we have 1/2 of 12 times 6. And 1/2 of 12 is 6, and 6 times 6 is 36. So that section's area is 36 square meters. Forgot to put my label down there. And now we can add them together. So 36 plus 48, 14, carry the 1, and, oops, thought that was eraser. We got 84 square meters for the total area of the composite shape.